Hello, space enthusiasts. Today, we're diving into a pressing issue that's been escalating over the years: space debris, commonly known as orbital junk. This topic might not always make the headlines, but it's becoming an increasingly significant concern for space missions, satellite operations, and even our daily lives. Imagine looking up at the night sky, marveling at the stars, planets, and the occasional passing satellite. What we don't see with the naked eye is the vast amount of debris orbiting our planet. Since the launch of Sputnik in 1957, humanity has been sending objects into space, and not all of them have made their way back down. Over time, defunct satellites, spent rocket stages, and fragments from disintegration and collisions have accumulated, creating a crowded and hazardous environment in low Earth orbit LEO. As of 2024, the European Space Agency, ESA, reported that space surveillance networks are tracking approximately 35,000 objects larger than 10 centimeters in Earth's orbit. Alarmingly, it's estimated that over 1 million pieces larger than 1 centimeter are also out there, each capable of causing catastrophic damage to operational spacecraft. This growing cloud of debris poses a significant threat to both manned and unmanned missions. The surge in satellite launches has exacerbated the problem. In 2023 alone, more than 2,800 satellites were launched into LEO, primarily for commercial communication constellations. Notably, 2/3 of all active satellites now operate between altitudes of 500 and 600 kilometers. This concentration increases the likelihood of collisions, which can generate even more debris, a scenario known as the Kessler syndrome. If this cascade effect were to occur, it could render certain orbits unusable for generations. Recent incidents highlight the immediacy of the threat. In August 2024, a Chinese rocket stage disintegrated after deploying its payload, creating over 700 pieces of debris. This event endangered more than 1,000 satellites and other space objects, raising concerns about the long-term sustainability of space activities. Similarly, in December 2024, a large metallic ring, identified as a separation ring from a rocket launch vehicle, fell near Mukuku, Kenya. Weighing approximately 1,100 pounds and measuring 8 feet in width, its unexpected descent alarmed local residents and underscored the risks posed by uncontrolled re-entries of space debris. The implications of space debris aren't limited to space missions alone. The increasing clutter in orbit poses a growing risk to air travel safety. Research published in early 2025 indicates a 26% annual chance of uncontrolled space debris re-entering busy airspaces, such as those over the northeastern United States or northern Europe. This risk has already prompted safety measures, including the activation of debris response areas by aviation authorities. The potential for collisions between space debris and aircraft could have severe economic repercussions and endanger human lives. Addressing this complex issue requires global cooperation and proactive measures. The United Nations has called for the creation of a comprehensive shared database of orbital objects to enhance space traffic management. However, challenges persist as some countries and companies are hesitant to share data due to security and commercial concerns. Despite these obstacles, it's imperative to establish a centralized system for space traffic coordination to mitigate collision risks and financial damages. Efforts are underway to improve compliance with space debris mitigation guidelines. In 2023, approximately 90% of rocket bodies in low Earth orbits left valuable orbits in compliance with applicable standards, with more than half re-entering in a controlled manner. These measures aim to reduce the amount of debris and prevent future collisions. However, the high number of existing rocket bodies and debris in space means that uncontrolled re-entries will likely remain a challenge for years to come. Technological innovations are also being explored to tackle the debris problem. Concepts such as active debris removal involve capturing and deorbiting defunct satellites and large debris pieces. Additionally, designing satellites with shorter operational lifespans and ensuring they can deorbit themselves at the end of their missions are steps toward minimizing future debris. However, these solutions require significant investment, international collaboration, and the development of new technologies. The urgency to act parallels past environmental challenges, such as the banning of chlorofluorocarbons, CFCs, to protect the ozone layer. Just as collective efforts led to environmental recovery on Earth, a unified approach is essential to ensure the long-term sustainability of space activities. Without decisive action, we risk reaching a tipping point where space operations become increasingly hazardous, limiting our ability to explore and utilize space for scientific, commercial, and societal benefits. In conclusion, space debris is not just a distant concern for scientists and astronauts. It's an escalating problem that affects all of us. From the potential hazards to air travel to the threat of hindering future space missions, the ramifications are profound. As we continue to advance technologically and expand our presence in space, it's crucial to address the debris we've left behind. Through international cooperation, stringent regulations, and innovative solutions, we can work towards preserving the space environment for future generations. Let's stay informed and advocate for responsible practices to keep our orbit safe and sustainable. If you found this video fascinating, don't forget to like, subscribe, and hit that notification bell so you don't miss our next video.